Hello students, so welcome to the online video tutorial. So today we'll be discussing from the same chapter memory and input output ports. Today we'll discuss about cache memory and buffer. So let's move on to the video. What is cache? So a cache is a very high speed temporary storage area which improves the computer overall system performance. So it is a very high speed, very high speed storage area, but it is temporary. It does not store the data permanently. Okay, so cache memory, it uses a fast static RAM, which was discussed in the earlier video. Okay, I provided a link for that. So static RAM, that is SRAM. So we have two types of RAM, that is the SRAM and DRAM, dynamic RAM, right? So dynamic RAM is much slower than the static RAM. Okay, so that helps the microprocessor to access certain data quickly. So with the help of this cache memory, the microprocessor can access the data much faster than from a normal RAM. Okay, so it acts as a buffer between the processor and the main memory, that is the RAM. So the cache memory, okay, is it acts as an interface, okay, or as you can say, the messenger between the processor and the main memory. Now you know that any kind of data that has to be processed has to go through the main memory first, right? Has to go to the main memory and then from the main memory to the processor. So the cache memory is responsible, okay, for catching those data and processing those very fast. So when searching for information, processor first goes to the cache and checks if data are stored, okay, and if the data are stored there, okay, then the processor process those data and then transfer that data back to the RAM, okay, and then from the RAM to wherever the data has been used. Okay, now if the data are not stored in the cache memory, okay, then the processor will move on to the search data to the slower memory storage area, that is the RAM. Okay, so cache stores the most frequently accessed data, the data which is being used repeatedly, okay, by the CPU. So so instead of going to the RAM to and fro again, okay, that data which is being used frequently is stored up in the cache memory as long as that particular program is running. Okay, so yes, RAM is also fast, but cache memory is the fastest. Okay, so instead of going back and forth to the RAM, okay, the data which is needed immediately, okay, and to be processed repeatedly is stored in the cache memory. Okay? So because cache memory is much faster than the normal RAM, so based on that, you have two types of cache memories. Okay, that is level 1 L1 cache or level 2 L2 cache. Okay, yes, we have also these days we have also L1, L2, L3 cache. Okay, so L1 is located inside the processor's chip, that is inside the microprocessor. Okay, the L1 cache is built in there. Okay, and L2 cache is located outside of the processor, that is it is attached onto the motherboard. Okay, so these days you will find that in 12 processors, 12 core processors, that the L1, L2, L3 cache are also in the processor. Okay, now even if it is located on the motherboard, okay, is attached on the motherboard, the cache memory, okay, will be located near to the processor, near to the microprocessor, so that it can access the data fast. Okay, so when a running program wants to access data from the disk, okay, then it first checks the L1 cache, because L1 cache is the fastest of all the cache memory. Okay, and if the data is not found in the L2 cache, then the microprocessor goes from the L1 cache to the L2 cache. Okay, and then if further it is not found there, then finally it will go to the slower memory storage area, that is the RAM. Okay, so keep in mind that cache memory is very high speed storage area. Okay, and the data which are being frequently used will be stored in that cache memory, so that the processor did not go back to the RAM to and fro again and again. Okay, so here is a diagram of what's happening, the block diagram. Okay, so here you have your CPU, that is your microprocessor. Then so inside the CPU you have your these days inside your CPU you have your L1 cache, L2 cache, like that. Okay, so the CPU will check in L1 cache if the data to be processed are there or not. If it is there, okay, the CPU will process that, okay, and send it back to the RAM. Now if the data is not found in L1 cache, then the CPU will check in L2 cache. Okay. After that, it will send it to the RAM memory. Then the RAM memory, okay, the processing it, okay, then it will send back to the CPU. Okay. So this to and fro process goes on between the CPU, the cache, and the RAM. Okay. So like as in the diagram, okay, the cache memory, okay, acts as the you may call it as the mediator or the interface, okay, between the CPU and the RAM memory, the main memory. Okay, now it is that, okay, you may have a higher processor, but it all depends on the cache memory. So the higher your cache memory, okay, the faster your processor will process the data. Okay, yes, it also depends on the RAM, but the better the higher the cache memory, okay, the better your CPU will execute. So that means your CPU will not stay idle while waiting for the data. Okay, so next we have is buffer. So buffer, it is also a temporary storage area. So this is shared by hardware devices or program processes that operates at different speeds and priority. Okay, so buffer, this is a part of the main memory, that is the RAM, okay, where CPU can store and access data temporarily. Okay, so buffer, using the buffer you can edit data, but with cache you cannot. Okay, like an example I have given here, when you are watching a video online, say like in YouTube, so the buffer stores the videos into frames, and the next frame that is to be displayed, okay, next, so that the video is watched without interruption. Now if you're watching a video in YouTube, you will see that below the YouTube video, there that line, that line is there where the duration of the video is given. Suppose it is 10 minutes, right? And you can see that as the line cursor, it moves from left to right. Sometimes you may notice that a red highlighted line, okay, inching closer to the end of that 10-minute video clip. So what happens is that you will see that uh, the line moves forward to the right side, right? So what happens is that that is the buffer, that is the buffer zone. Okay, the buffer catches while you're watching, suppose like just examples, while you're watching a 10-second movie, okay, the buffer in the buffer zone, okay, the next 10-second clip will be stored in the buffer zone, so that uh, you're watching the video, okay, continuously. Okay, so once the 10-second video clip of the next is watched, okay, the buffer zone gets stores the next 10-second video clips, that means the next frame. Okay, so frame by frame the video is being stored in the buffer zone area. Okay, so you can also make edit on it. You can also go back and then, yeah, you can rewatch the video like that, right? So buffering is very important also. Okay, when so just like cache memory, okay, it's also stores the data temporarily. But here what you do is that buffer is related with the input output process. Okay, so you can make changes to the data also in the buffer zone area. Okay, so I hope that you have understood what is cache memory and buffer. Okay, There are also some you will also find some YouTube tutorial links, okay, with images and animations and diagrams like that, okay. So you can also watch those videos, okay. So today so that will be all for today, okay. So you also study from the textbook more about the cache memory and the buffer.